Welcome to the video on artificial neural network part 1. So what is artificial neural network? It is mainly used for building a classifier. It can also be used for estimation. It is a type of supervised machine learning because it has independent variables and response variable. The name is loosely connected with how neurons work in human brains. However, this topic is quite debatable and some people don't even agree with it. It is a basic building block of artificial intelligence. So we have some examples of artificial intelligence in real life, like Amazon's Alexa, then Sophia robot, chatbots, and etc. So it was first conceived in 1943 by Warren McClough and Walter Pitts. What they did is they developed an algorithm called threshold logic, which is a basically computational model for neural networks. And from here, actually, there was a diversion, and neural network was developed from there on. So artificial neural network, this is how it looks like. So you see, it has different layers. You can see here, and each layer has nodes. So these are called nodes, actually. You see. So the first layer is called input layer and the last layer is called output layer. And in between all the layers are called hidden layers. So here we have, in this example, we've got 3 hidden layers: first hidden layer, second and third. And all these connections that you see, so this is like fully connected neural network. So here each node is connected to all the nodes in the next layer. You can see this blue lines going here, there, everywhere. Same way, this node is also connected to all the nodes of this layer. Likewise, this one. In the next layer also same thing is happening. All the nodes of this layer are connected to all the nodes of this. Same here and same here. You can see that. Now, what are these connections? These connections are basically different weights. Like we know coefficients in logistic regression and linear regression, we have seen the weights or parameters or coefficients. So these lines represent coefficients. That means uh, this each node, and here this is input layer. So each node represents, in input layer, each node represents an independent variable from the data set that we have. So in this example, there are 4 independent variables. That's what we can see. So here you see this neural network differs from any other like logistic regression or any other classifier or even linear regression, because for each input uh, independent variable you have so many coefficients, not just one coefficient. So since in the next hidden layer there are 6 nodes, so each input layer has independent variable has got 6 different coefficients corresponding to 6 different nodes in the first hidden layer. Likewise for this and this and this. Now as we move on to the next layer, even this one has got 3 connections because there are 3 nodes in the next layer. So this also has got the 3 different coefficients or parameters or weights, whatever we call. Likewise all these nodes. And here, since in the next layer there are 2 nodes, so this has got 2 coefficients or 2 parameters. This one also 2, this one also 2, and these in the last there are there is only one node here. It's not that this is the output layer can have so many nodes also. Here in this example, our classifier has our classifier classifies only 2 classes, 0 or 1, but if you have more classes, more than 2, then you need to have that many nodes here in the output layer. So again, here this has got one coefficient, so this is how it looks like. This is just an example. So types of artificial neural network. So there are mainly 3 types of neural networks. So first one is called the classic, the one we saw in the previous slide. It's also known as feed-forward neural network. It is multi-layered. It can just have simple in one input and one hidden layer and one output layer. That is also possible. And it is unidirectional. So data flows from input to hidden and it goes on straight. It follows straight line that way. Then we have another very famous type of neural network which is used extensively in deep learning. It's called recurrent neural network. Basically, it deals with sequential data. So data which is which has time factor, like you have time series data, so that kind of data, and it flows in multi-directional. So it is more complicated neural network, unlike the classic neural network. So there are many components in this. This itself requires a lot of deep understanding and learning, and it requires a lot of training to understand this whole architecture. There are different types of recurrent neural network. It's called, short form is RNN. So it deals with cases like NLP, natural language processing, sentiment analysis, music generation. Wherever you have sequential data, it works like one to many, many to one, many to many. That kind of method it works on. Mapping it works on. So then the third one is convolutional neural network. Basically, it is designed to deal with computer vision problems like image processing, face recognition, auto driving cars, because they keep capturing the images in in different frames, although it looks like video, but then video is broken into different frames, and then it works on this convolution neural network. It actually classifies the objects, and accordingly the car moves, changes direction. So simple example. Benefits and application of artificial neural network. So neural network can deal with very complex problems actually, unlike these any normal classifiers. So that is one advantage of this. It has the ability to learn by itself. Even a complex pattern in the data uh, can be learned by neural network. Then learning can be transferred to other problems easily. What it means is, like, the companies like Google and there are other big companies, they train huge network of neural network. So neural network, what we saw is very simple. There could be hundreds of hidden layers depending on the complexity of the problem. So Google, for example, the Google search, how it works, then you type something, it automatically predicts what are going to be the next words or lines in your search. If it has become very advanced now, it works on translation. Then if you provide a particular text in a particular language, English, and you want to translate it into Spanish, Hindi, Italian, it will do that very efficiently. All these things work on data science only, I mean neural network only, a predictive model built based on neural network. So they train a huge network with so many hidden layers. So that means so many parameters, right? So what how it helps is, like, suppose you are building another uh, model, predictive model, and even your problem is quite complex. So what you can do is you can pick up some of the hidden layers from the model that has been trained by these companies like Google, or if they provide you for free, or I'm just giving an example. It could be some other organization also, or if it could be your friend who has trained a huge neural network, with so many hundreds of hidden layers. So, and if you see that, okay, that kind of training model can help your problem, so but you need to tweak it little bit. So what you do, you take most of the hidden layers, and then you just change the last few hidden layers and output layer. You train only those last few hidden layers, but the rest, or rest of the hidden layers have already been trained by the other organizations. So that's why this learning can be transferred. So data is stored inside the network itself. So you don't need a big database. So again, if there is a loss of data, it can still work. So they learn from the mistakes, faults, and adapt to changes quickly. All the neural networks, they have this ability. Then applications. So as we saw, like computer vision, image processing, face recognition, natural language processing, translation, sentiment analysis, etc. Then speech recognition, then text to speech, speech to text. All these are examples. Now architecture of NN. So we saw this example, right, in the previous slide. You have input layer, first, second, third hidden layers, and then output layer. So following are the components. What are they? So one input layer, of course, neural network will have one input layer. Then it will have multiple hidden layers. Okay, at least one hidden layer for classic neural network. Then one output layer. So you need to use this output layer to basically predict what you're trying to predict. A number of nodes in each layer. So you have nodes here, right? So first, in input layer, each node represent one independent variable. and then these are different features that your neural network will learn. Each hidden layer will learn, something, some feature, some aspect of the data. So if you have more hidden layer, it will learn more number of, but that doesn't mean that you need to, you keep adding hidden layer. If it's unnecessary, then you don't need to. Then you have activation function. What happens is, this node will have this, the first input layer does not have activation functions, but all the other layers have got activation functions. So each hidden layer will have one activation function, and each node will work on that activation function. So what happens is, this particular node will receive data from all these four input nodes, right? Because it is connected to this, it is connected to this, it is connected to all these nodes, and these lines represent weights. So what we do is we multiply the value of this with the respective weight, and then we do the same for all the nodes, add them together and supply them to this node, and this node will use this linear equation and use an activation function to create a value, and that is applied to the next. So that becomes input for this layer. So that, and similarly we do it for all the nodes. So that is why we need activation function. So steps in neural network, basically there are mainly two steps in neural network: forward propagation and back propagation. So we will see that in later videos. So thank you so much for your time, and this was just an introduction. We will go deeper into other in this neural network in other videos as well. Thank you.